Webb's near-infrared imager and slitless spectrograph, NIRISS, measured light from the WASP-96 system for 6.4 hours as the planet circled its star, and brought us this light curve of the brightness of WASP-96b's parent star over time. Webb has just brought us beautiful pictures, and a lot of us were awestruck, but some of its most amazing observations won't come from beautiful pictures. Recently, Webb captured the most detailed spectrum of an exoplanet's atmosphere ever. You've probably heard about WASP-96b by now. It's a gas giant about 1,150 light-years away in the southern sky constellation Phoenix. This hot, puffy gas giant is like no other planet in our solar system. It has a mass less than half that of Jupiter and diameter 1.2 times greater. WASP-96b orbits astonishingly close to its Sun-like star, just 1/9 of the distance between Mercury and the Sun, completing one orbit every 3.4 Earth days. That's so close that its parent star is boiling away its atmosphere. Temperatures here are greater than 1,000 degrees Fahrenheit. So what's crazy about the recent observation is that the Webb telescope has detected the distinct signature of water on WASP-96b, along with evidence for clouds and haze. This isn't the first time a telescope detects water molecules on another exoplanet, but Webb's super-powerful 21-foot mirror, over 2.5 times larger than Hubble's, gives us the most detailed analysis to date. Webb's near-infrared imager and slitless spectrograph, NIRISS, measured light from the WASP-96 system for 6.4 hours as the planet circled its star, and brought us this light curve of the brightness of WASP-96b's parent star over time. As the planet transits the star's disk, its light dims. Another result of this observation was the transmission spectrum, which reveals the brightness change of individual wavelengths of infrared light between 0.6 and 2.8 microns. Thanks to this transmission spectrum, we now have access to previously hidden details of the atmosphere, the distinct signature of water, indications of haze, and evidence of clouds that we never thought existed before. Astronomers make transmission spectrums by comparing starlight filtered through a planet's atmosphere as it moves across the star to the unfiltered starlight. Then, absorption patterns, the locations and heights of peaks on the graph, will enable scientists to detect and measure the gases in a planet's atmosphere. The blue line on the graph takes into account the data, the known properties of WASP-96b and its star, like the size, mass, and temperature, and the characteristics of the atmosphere. Only Webb's advanced design can make such exceptional observations. Its 270-square-foot gold-coated mirror collects infrared light efficiently. The precision spectrographs spread light out into rainbows of thousands of infrared colors, and the sensitive infrared detectors measure extremely subtle differences in brightness. Also, Webb is extremely stable and orbits around the second Lagrange point about 1,000,000 miles away, which keeps the telescope away from the polluting effects of Earth's atmosphere. Thus, Webb has an uninterrupted view and clean data that can be analyzed very quickly. Such observations will help us understand the birth of gas giant planets like Saturn and Jupiter, clock climate patterns sweeping around them, and maybe enable searches for signs of life. If you like this video, please consider subscribing and click the notification bell so you do not miss any upcoming videos.